Can you all hear? Welcome. We're all going to Hangout, Google would say. We have a few questions that we are going to try and answer. We have a few questions from the survey, the questionnaire that was circulated to you. We'll start with those questions and then we're going to go into answering a few more questions. We'll take your live questions. Okay, is my voice clear? We have Saurav, Alvin, Rohit, Sonu, and Shubham online. So can I get a yes from all of you?
Yes, sir.
Okay, very good. Very good. So we'll get started then. The first question has to do with trusses. It says, in a truss system, does the length of the members affect the internal force in them or their load sharing capacity? Yes, as a matter of fact, there's two things you need to remember. You're talking of a truss. In a truss, each member is only a tensile or a compressive member. In a truss, there is no bending moment that is sustained by a member of a truss. Okay? So when I have a member of a truss, it is either being pulled or compressed. In that situation, the length of the member itself does not matter. So in other words, we assume that it is able to withstand tension or compression over the entire length. So if I take a slice at any point, the internal force at that point is only normal to the slicing plane. There is no force or bending moment perpendicular to the slicing plane. So therefore in a truss, it does not matter. But in a beam, it of course matters. We've done examples where you see these things like PL over EI. L is essentially the length of the beam. So in a beam, it does matter. Okay. Now let's come back to trusses. In a real truss, though, let's say you look up at the truss bearing the roof at the central station. You cannot make the members infinitely long and still hope it will bear the load. That is because of either buckling, which is a secondary effect that is not included in our standard truss analysis, or tensile failure. We of course assume that the material that each truss member is made out of is able to sustain the tensile load that we calculate it is supposed to bear. Okay, so I hope that answered that question. The second question has to do with friction. I could not understand friction even after going through the book. Okay, so friction is actually a very interesting force. Like I said in my lectures earlier on, we will focus. Let me first answer the part related to static friction. So when we are dealing with static friction, if I take a block, let's say I have this block on my palm, right? Now if I begin to push it, the force exerted at this juncture between my palm and this body is exactly equal and opposite to whatever force I'm pushing this with. So it is not equal to mu times the normal reaction. If let's say the weight of this block is 1 kg or 10 newtons, and if mu between my palm and this block is, let's say, 0.5, 10 newtons is the weight of this body times 0.5 is 5 newtons. So at this juncture, at this interface between my palm and the block, a force of 5 newtons is capable of becoming developed. But that does not automatically mean that there is a force of 5 newtons. Let's take a trivial example first. Let's say the block is standing on my palm. There is a weight and a normal reaction. Those are the only two forces. When there is a weight and a normal reaction, there is no friction. Even though the maximum friction force possible is 5 newtons, the friction force right now is 0. Now if I begin to push this with a force less than 5 newtons, the force exerted by the palm on the body is exactly equal and opposite to whatever this force is. If this force that I exert becomes greater than 5 newtons, then the force exerted by the palm on this body is exactly still equal to 5 newtons, which means mu times n is the maximum possible force and not the force that is exerted always. So this is the first confusion I see among students, that the friction force mu times n is the maximum possible friction force at any interface. The actual friction force would be less than that or equal to that, depending on the force that is trying to overcome or create relative motion. So if you think of it this way, there is something that is trying to cause this sliding to happen, and all friction does is reduce the propensity to slide. It essentially tries to make the sliding become nearly zero. Okay, so that is essentially the rule of static friction. With dynamic friction, the argument is still the same, that mu times n is the maximum possible friction, but in a dynamic case, friction is not opposing the movement of the center of mass. Friction is only opposing relative motion at the point of the interface. We looked at the last example from week 5, should have shown you this. Sorry, the one of the examples in week 6 will show you this, that friction is actually causing motion in many instances. Like for example, if I take a car, you are at rest at a traffic light, you hit the accelerator, what happens? The front wheel experiences a moment due to the engine. That moment causes the front wheel to try to turn, but the friction between the road which is my right palm and the wheel is actually causing the wheel to go forward. So the wheel going forward is entirely due to friction only. The engine is not playing a role. The engine in the car is creating a torque, is creating a moment that is causing the wheel to try to accelerate in an angular sense. And it is actually friction between the road and the tire that causes the forward motion of the car. In automotive engineering, people call this traction. So essentially, traction is the forward driving force, and that is entirely due to friction. And that value of the friction does not necessarily be equal to mu times n. It will be whatever is needed to cause relative motion to come down to zero. The minimum force needed to cause relative motion at that interface to come down to zero is what we see actually manifest as friction force. And the real value, the maximum possible friction force is mu times n. So if I hit the gas pedal all the way down, right at a red light, you see the front wheel spin, which means that road is exerting a force equal to mu times n. That is our traction force. But the wheels are still slipping, which means that the friction force is not sufficient to create complete traction. There is slippage at the front tire. Okay, I hope that answered that question. Let's take the next one here. It says, hello sir, I want to ask how will the questions in the certification exam either objective type or subjective? Can you please provide me a good model of this? You should certainly have a model very soon. If it's not already uploaded, you should have a model question paper for you to all see. The questions would be very, very similar to the assignment questions. You've been answering the assignment questions. You should really have no problem in answering the questions on the real exam as well. They will be objective type for the most part, but not necessarily all multiple choice. There will be a few multiple choice questions, but some that require a numeric answer from you. And the numeric answer is judged based on a range that we give, a correct answer should fall in. So we don't expect you to get the answer to 3 decimal places, but we do expect you to be on the right track. If you're on the right track, you should be able to get an answer that is within the limits that we would have set as the correct answer. So these are going to be the 2 main kinds of questions, either multiple choice or numeric answers. The numeric answers are where you would solve the problem on your own rough sheet of paper, but we want you to enter the answer into the answer sheet that is provided in the online exam. Okay, I hope that answered that question. We can take more questions on the online certification later on as you see the need for it.
Yeah, let me just intervene. So there will be a calculator that will be available on the portal that you will be answering the questions on. So you need not bring your own calculator. There will be a calculator which you can use on screen, and it will have all kinds of basic functions with which you can get the numerical answer. Yeah.
Oh, by the way, this is Rohit. You've been getting all the emails from him. So he's our very able teaching assistant for this course, and I hope he's answered many of your questions as well. Let's move on to the next question. I'm pursuing first year BTech from SKIT Jaipur. I'm in mechanical engineering. I want to become an aerospace engineer. So my college is not good, like a reputed college. What should I do? It says you're also interested in computer science. I would like to change my branch. If you guide me, how to reach my aim, how to complete my dream. Okay, this is a bit unrelated to engineering mechanics, but I'm very glad to see these questions, especially that relate to mechanics as a whole. Now you are in mechanical engineering. The particular student that asked this question says he is in mechanical engineering, but wants to shift to aerospace engineering. In most colleges, you are allowed to take a few electives that you can take inside your college to kind of do some subjects that you like. This is also true. This is true at most colleges. But one of the main reasons we have NPTEL is to facilitate you learning what you want to learn, irrespective of the branch you are in. So if you are in aerospace engineering, all the basic aerospace engineering courses are available online. Propulsion, combustion, flight control and guidance. All of these are available online. You can go on nptel.ac.in and watch any course you would like to watch and learn the material. That does not give you a degree in aerospace engineering, but certainly you can begin to acquire a sound understanding of the fundamentals. And beyond that, these certification courses are also being expanded. This is only the second semester we're doing this. We have about 12 courses happening as we speak, one of them being our engineering mechanics course. But we're going to expand these courses quite rapidly over the next semester or two. So you will see a lot of other disciplines, not just computer science, electrical engineering and mechanical engineering come on board. So you will be able to get certification also in the other disciplines of engineering. The biggest chance you have to switch to aerospace engineering is after your BTech. So you finish your BTech in mechanical engineering, and then when you choose to do your MTech, you can choose to go into any one of many branches, including aerospace engineering, even chemical engineering, electrical engineering, computer science. All of these branches are up for grabs. You just have to take the GATE exam in the particular discipline, and then you can choose to become a student of aerospace engineering in many colleges. Now, mechanical engineering particularly is a very good branch to start off in, because you get the fundamentals of a lot of different branches of engineering. But having said that, in this day and age, any kind of a BTech is only to be construed as a basic degree in engineering, and that you really want to be doing an advanced degree. You really want to do a postgraduate degree to really become a specialized person. So that's my sincere advice to you, sir. Let's go on to the next question. I just need to know whether it is true that if a certain point of a rigid body, not necessarily center of mass, is taken as the point about which rotation is analyzed, then with respect to that point, the entire body executes pure rotation about its axis through the given point, though the given point remains or at least at rest. Kindly clarify. We talked about rotation. So the basic idea of a rigid body is that you have, in plane kinetics, you have 3 degrees of freedom. The body can translate horizontally, translate vertically, and rotate. One of the points I repeated many times in my lectures is that when the body rotates, it is not rotating about any point. It is rotating about every point, meaning every point is rotating about every other point with exactly the same angular velocity. We showed that in one of the examples. Now, but in this general case, there could be a fixed point, that is, a point about, if I choose, you could find one point about which there is only rotation. There is, in other words, if I fix my coordinate system at that point, all the points appear to rotate about that as though that was a fixed point. You could find this fixed point for most rigid bodies, and in a real situation, the fixed point may lie anywhere on the body or not on the body. Okay? But it does not have to be the center of mass. It is never the center of mass in general. It could be the center of mass, but there is no reason to expect it is the center of mass. The point I made earlier on was that if I choose the center of mass to compute my moments, then I do not have to worry about the actual state of the center of mass. It does not matter if the center of mass is accelerating or if the center of mass is at rest. Sum of moments about the center of mass is equal to the moment of inertia about the center of mass times the angular acceleration. This nice simple form of Euler's second law applies if you choose the reference point as the center of mass. That was the point under which I brought the center of mass into our discussion. Okay, all right. So let's go on. In assignment 4, question 2, are we considering the topple case also?
Okay. Yes, I'll go to that. I'll probably do that later.
Okay. Yeah. All right. So Rohit will take a question and answer that. Answer choices to question 4 of 5th assignment are not having the correct answer. I think the third choice has to be 3.77 instead of 2.77. We'll get that taken care of also towards the end. So I've been following, we'll go to the next question. We've been following engineering mechanics. Where can I find extra problems on this syllabus so that I can get confidence about solving problems? If you go back to our earlier course outline, we had put out 3 references in there. One was a book by Merriam and Craig. The second was a book by Johnston, Beer and Johnston. And the third book the second book was by Hibbler, and the third book was by Lakshman Rao and Shivakumar. All 3 of these books have excellent example problems. You are welcome to solve those problems, and if you have questions or if you get stuck with one of those problems, please post it on the forum. Rohit or I will be happy to look at it and do it. Here I see a comment pop up that most of the foreign books are not SI units, and you're right. So, well, there is only 2 choices there. The third book that I talked about, Shivakumar and Lakshman Rao, is entirely in SI unit, so you're welcome to use that. Or the last part, which is the last suggestion I have, is that it probably does not hurt to solve the problems in a symbolic way and then substitute numbers at the end by simply converting all the numbers in the problem to SI units. That would probably be a simple way of solving the problem. Now, if you're able to solve the problem without getting stuck and you have no way to compare your answer, that's fine. I would say that even if you are able to solve the problem, if you get stuck, do call on us. If you are even able to solve the problem but you're unsure of the answer, post the problem number and the answer, and we'll be happy to solve them and check them out for you as well. Okay, I hope that answers the question related to the units. All right. How to prepare basics for mechanics for gate exam? I will say the mechanics part of the gate exam is certainly based on the material we are discussing in this course. The assignments that we have in this course are at a level slightly below gate exam typically. But I will be happy to provide additional reference material towards the end of the course for those of you that are interested to start here and go towards gate. So I will post additional material that you can use to get there. Okay, I hope I answered those 3 questions. Let's see. I have one last question related to exam timing. The exam is going to be a 1.5 hour exam.
3 hours.
Yeah, the exam is going to be a 3-hour exam, and like I said, it's going to involve both multiple choice as well as numerical answer questions. So come prepared, and it should be a fun exam.
So mostly it will be from 2 p.m. to 5 p.m. It's not yet being communicated to us by NPTEL, but yeah, I'll get back to you and I'll send out an announcement as soon as I get to know of this. Yeah.
Okay, so we can now. That's all the questions I had from you before. From the Google questionnaire. So we can now take live questions for those of you that would like to start us off.
Yeah, so I'm just trying to give volume to, I'm moderating this conversation. So let me just give volume to all the speakers who are recorded. Yes, so you can unmute yourself and try to speak. Shubham, can you speak? Shubham?
Hello?
Yeah, we are able to hear you.
Yes, sir. Can you hear me?
Yeah.
1 minute, please, sir.
Yeah, please go ahead.
Please explain.
Sir, good evening, sir.
Good evening.
Hello, sir.
Yes, Shubham, we are able to hear you.
A very good evening, sir. Sir, my question is, hello?
Yes.
Sir, my question is in the stress system.
Yes.
Sir, my question is in the stress system, does the length of the members affect the internal forces in them or their load carrying capacity?
Shubham, I think you asked this question in the Google questionnaire as well. I did answer that question in some detail at the start of this Hangout. You can go back, look at the answer when it is on YouTube at the end of this. But I'll give you the short answer. In a truss, it does not matter, because in a truss, the load-bearing element is only either under tension or compression. And when something is under tension or compression, the length of the member itself does not matter. So the short answer is it does not matter, but you can get a detailed answer from the front of this when it is on YouTube.
Anupam has a quick question.
Yes, Anupam.
Anupam, you can speak.
Anupam Gurjar.
I think he wants to say what happens for an indeterminate structure.
So, did you have a question? Anupam, your question has to do with an indeterminate structure. No, even in an indeterminate structure, if you're asking if the length matters, the answer is still no. The length still does not matter. But in an indeterminate structure, you're just either over constrained or under constraint. If it's under constraint, it essentially becomes a mechanism, and because you start to develop a degree of freedom. But if you are that's all. That's essentially because when you're over constrained, what happens is the way you build the structure now determines whether something is preloaded or not. Therefore, that is where the indeterminacy comes in. You cannot analyze indeterminate structures from simply the final structure that you get in a drawing. The actual order in which the beams, order in which the truss members were assembled will begin to play a role. Okay. All right. So I think that answered that question as well. Anupam, can you come online and describe what you have with unit load method?
Someone else.
Okay. Someone else that has a question? Anupam, we are unable to hear you. If you would like to say something, you can unmute your microphone and then say it.
Yeah, so anyone who has a question, please go ahead and just ask it straight away.
How have you been finding the first half of the material, the statics part? The statics part was all lectures by my colleague Professor Shivakumar, and but we contributed the assignments to it. Now, the essential parts of statics that were covered were analysis of trusses and analysis of beams. And we want to make sure you have a good grasp on these two aspects, both analysis of trusses and analysis of beams. When it comes to beams, you're essentially going to be looking at bending moments inside the beam as well as shear force loads inside the beam. And you can, so both those forces, you should be able to analyze those effects that 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 you can use in the analysis. Okay, Shubham, I see a quick question from you about the length of the beam not being clear. I think I'll give you the short answer again, that the length of the beam does not matter because the beam is only under tension or compression. So it doesn't matter how long the beam is. It can be this long or it can be short, as long as the cross section of the beam is able to withstand the normal stress, either tensile or compressive. That would suffice. Okay, there's one more question related to the number of zero force members in a complicated truss problem. How do you find the number of zero force members? In a complicated truss problem, there is no easy way to straight away get to the number of zero force members other than to analyze it pin by pin. So if you take a pin, you do a sum of forces in x direction is 0, sum of forces in the y direction is 0. That would usually tell you each zero force member if there is such one at that pin joint. So you work through the truss pin by pin, and you would be able to identify whether the truss has zero force members, and if so, how many. So that doesn't come through a standard formula that in a given general truss you are able to identify zero force members. So in a general case, for example, I could have an indeterminate truss and still have zero force members in the indeterminate truss. There is no reason to not have that. So it is not clear how you would get that straight away. You have to do it pin by pin. Okay, Mr. Sonu Kumar has a question. My question is regarding syllabus taught in IITs and other colleges. Can IITs and IISc make efforts to make syllabus the same countrywide so that every student can study the same? Yes, so this is exactly a step in that direction. In fact, at the curriculum level, there is already some standardization that say a particular university sets an exam, and the curriculum that goes into a particular university's exam is set by the university for all colleges. So there is some standardization, but I agree that we are still a long way to go before you have standardization across IITs, IISc, and all the colleges. But NPTEL is essentially a step in that direction, where whether your college teaches to a standard or whether an IIT teaches to the same standard is not going to matter, because come gate time you can follow NPTEL lectures and they would all be at this, we would all be at the same level. So I think this is a great way to bring about that standardization without mandating it through some kind of a legislation or through legally getting it in there. Okay. So this kind of using internet to get material directly to you is a very simple way to make sure we are all on the same page. Yeah, I hope that answered your question, Sonal. Let's go on to the next set of questions. I want to invite questions on the exams. And first of all, how many of you have registered for the certification exam? Can you please go through quick? Give me a yes, yes, yes in your chat window, just so I know how many of you have registered for the exam. A quick count. Okay.
So on your left, the left top corner of the screen, you can just go and click on the chat option so that you can see the group chat if everyone is not able to see it. So we're discussing all the questions in the group chat. If you're not able to speak directly, you can also speak directly if you unmute yourself. If you want to directly speak and ask a question, please do so.
The exam center information is not yet available to us. We will communicate that to you as and when it becomes available.
Is then the form they have to fill.
Okay.
So if you can see exam center information in the form that you have to fill. So if there is a particular exam center near Chhattisgarh, I think that would do. Otherwise, you would have to travel to the nearest exam center and give the exam.
Okay. Okay. I have one question. It says, is there any benefit of this certificate for those who complete their degree? The short answer right now is no. I mean, there is no direct benefit, meaning some job waiting for you based on this certificate. But we have a mechanism by which we want to make this certificate valuable to the community at large. And the way, so essentially when NPTEL, this online certification program is headed towards becoming a degree granting open university. We are still a few years away from that option, but I think as you accrue these certificates, you will become eligible for more advanced diplomas at some period of time. It has not been enabled yet, but when it is enabled, you will start to see the complete benefits. What we are seeing now is the start of that program. So at the moment, there is no direct benefit associated with the certificate, other than of course the knowledge that you gain. But in due course of time, there will be more to it. Now, is it going to affect my exams in this? You've not submitted the assignments. It is not going to affect the marks in the exam itself. You will still, the exam is an independent event. You will still be evaluated for what you write in the exam. But the certificate itself will be based on the assignments score, as well as a composite of the assignment score and the exam score. Having said that, we will take the best 3 assignments out of 8 to compute the assignment score. Which means even if you start submitting your assignments now, Anupam, you will still have 3 assignments. and those 3 assignments will count towards the certification score. So your final exam, certification exam, plus the 3 assignments that you can turn in between now and the end of the course should get you to the point just like everybody else. So I would urge you to get started. There is one assignment open right now. You can start by even submitting that, and that will give you an additional assignment to have included in your portfolio. So I hope that answered your question, Anubhav. Um, let's see. Anyone else that has uh, anyone else that has would have some questions about the certification exam? You can ask. I hear some people active on the voice. You're welcome to ask the voice questions as well, so everybody can hear. Um, to ask questions from other engineering entrance tests like CSIR Net. Now, CSIR Net or GATE are all structured on the same pattern of questions. They are all very similar. So I would say the material we're discussing in this course should form the basis for all of that as well. I don't think you need any special preparation for CSIR Net that is not included in GATE. Having said that, the mechanics part in CSIR Net would be smaller than, let's say, in GATE mechanical engineering. So I think that would be my answer to your question. Mr. Vishwanath asked the question, regard of exams, what is the total score to be? That has been published.
The exam will be for 100 marks, and these assignments will carry a certain percentage towards the final score that you will get on the certificate. So this percentage has not yet been decided. Tentatively, it is going to be about 30 or 40%, and the rest of the 60% towards the final score will be from the final exam. The total marks in the final exam will be 100, and there will be about 3 sections, and all this information will be communicated to you soon. There's still about a month for the exam. So in about a week, I'll send out an announcement in which I'll detail as to how many sections are going to be there and how many questions are going to be there, and individual marks the questions will carry. So I hope that answers the question.
Okay. I have a question here on the unit of velocity in rotational motion. Velocity, in the sense of linear velocity, only has one unit, that is meters per second in SI units. Rotational velocity, often called angular velocity, also has only one unit, that is always in radians per second. Now, if I know a bar is rotating at a particular velocity, then I can calculate the relative velocity between these 2 points as the angular velocity times the distance between those 2 points. That's in a linear speed, relative linear speed between these 2 points. So I hope that answered the question related to whether on the unit side. Please suggest standard books for GATE exam. We will post some reference material that you can use to go from where this course leads you towards GATE, towards the end of this course. You can use that for your GATE preparation. Now, quickly, how many of you are interested in GATE preparation? Can you do a yes, please? Is it possible to do a quick vote? All right. I have one question. How is our course related to the area of robotics? Okay. I'll tell you the kinematics part, which was, I think, discussed in week 5, is completely all robotics. You saw those bars, pin joints, and essentially moving members. Those are all, you could construe them as robotic arms. So the field of robotics has 2 parts to it. One, the kinematics of motion. So for example, let's say my arm is a kinematic entity, right? So it's got 1 degree of freedom here, 1 degree of freedom here, 1 degree of freedom here, and let's say one more degree of freedom here. So 1, 2, 3, and 4. So this becomes a 4 degree of freedom mechanism. So if I want to make these fingers go from here to here, there's one of 4 ways of doing this. One, I don't do anything except raise this. I don't do anything except do that. I don't do anything except do that. And the fourth is using the other degree of freedom. So when I do this, I can study the kinematics of how the arm moves. When I do that, I'm not considering the forces involved in the motion. When I analyze this same 4 degree of freedom system using Euler's laws, I will also now be able to calculate the forces exerted at these individual joints. Okay? So when I do that, I will be able to calculate the forces exerted at the moment exerted at this joint to cause this rotation to happen. That would of course depend on the mass of my palm. When I do my kinematic analysis, I do not need to care about the mass of my palm. Whereas if I have to analyze the forces or the moments needed to cause this rotation to happen, I need to have some information on the mass of my palm. And that is where robotics comes in. So there's 2 ways. One, I need to understand whether I can go grab something, that's a robotic application. And second part is the forces and moments that are needed to make that happen. So both of these are, what the material we're discussing is certainly applicable to this area of robotics. What is the degree of freedom of a fixed beam? Actually, such beam has infinite number of deflections. That's a very good question, as a matter of fact. Think of it, when I look at my hand, I'm looking at discrete motion. So when my wrist is moving, everything else is fixed. A beam is actually deflecting continuously at every point. So you're absolutely right, Anupam, that it is in fact correct to think of it as an infinite degree of freedom system. That is essentially the start of where we start to treat deflection as a field variable. So I now can do a deflection along the length of the beam, and I can write a function delta as a function of x along the length of the beam. And that function basically means that given an x location, I can calculate delta, the deflection at that point. And the delta, the deflection at another point x is different, but still given by this same function. As opposed to a function, if I take this degree of freedom problem, or let's say if I just take 3 degrees of freedom, my shoulder, my elbow, and the wrist. Let's say if I just do 3 degrees of freedom, then the motion at this degree of freedom is decoupled from the motion of this degree of freedom. So these are discrete degrees of freedom systems, whereas a beam is you can think of it as a continuous degree of freedom system. Okay, so that is how you can actually go. Let's say if I had, instead of having 2 members, if I now thought of this as several tiny members, each one with a little pin joint, I'm now heading closer and closer to what my beam would look like. Okay, and so you can, the more the number of members I put, the closer I get to my approximation of a beam. Therefore, yeah, you're right in thinking of a beam as an infinite number of deflection system. Good. Any other questions? All right. So does anybody have any more questions to ask? What is, we have 2 questions. In vibrations, we study about complex coordinates. Are they useful in kinematics? Yes, we did not use the kinematics analysis using complex coordinates, but it is often used. It's a simple way to analyze analyze 2-degree of freedom systems, because you can decouple rotational and translational motions and study them separately. Although in this first level course in engineering mechanics, I prefer keeping the calculations as scalars. So treating the rotational degrees as in terms of relative motion and translational velocities and translational degrees of freedom separately. Okay, so that's the reason we did not discuss the application of complex coordinates to kinematics in this class. However, if you're interested, you are welcome to refer to any advanced textbook on kinematics, an undergraduate textbook on kinematics of mechanisms, and you will see the complex variable calculations of kinematic motion. Okay, we have one more question related to rolling resistance, related to the wheel and the road friction. Well, rolling resistance is different from Coulomb friction. All the time that we have been discussing friction, it is in the context of Coulomb friction. Spell out Coulomb. Okay, Coulomb friction, as the name goes, is essentially treating friction as it's a model of real friction. Okay, so you have to understand the difference between a model and reality. A model is basically our simplified version of what the real world is, right? So Coulomb friction is one such model. It says that the maximum value of friction is proportional to the normal force at the point of sliding. Okay, and the proportionality constant is some mu, which is our coefficient of friction. But more importantly, a Coulomb friction model says that the actual force, friction force exerted, does not depend on the velocity of sliding. So the actual friction force, if sliding is actually happening, then it does not. Then the Coulomb friction is not proportional or is independent of the actual sliding velocity itself. Rolling resistance, on the other hand, is different. Rolling resistance has to do with the fact that I have a wheel, let's say a rigid cylinder rolling on a surface, but the floor, the bottom surface, is not rigid. So what we see now essentially is, as this cylinder rolls, you see a depression. You see the bottom surface is depressed, and so it undergoes a deformation. And when that deforms, there is a normal reaction around the front of the deformation versus the back of the deformation. These two vectors do not add up to zero. The normal deformation on the front side of this little pit that is formed by a rigid cylinder sitting on a soft substrate, the normal force on the front side is slightly greater than the normal force on the back side. So the net result is that there is a net force that is trying to oppose the overall rolling motion of this cylinder. So just just to understand rolling resistance clearly, the rolling resistance between two rigid bodies, let's say a rigid cylinder and a rigid floor, is zero. You cannot have rolling resistance as long as you do not have any deflection. When you do have a deflection, whether it is due to a flexible cylinder on a rigid floor, or a rigid cylinder on a flexible floor, or both flexible, doesn't matter. When these vector forces do not add up to zero on the front and back side of this cylinder motion, then you get a net remaining force, which is called rolling resistance. This is the real physical origin of rolling resistance. Now we need a model. How do we get to a model of this rolling resistance? There are one of many ways. People have done experiments and done a curve fit that shows that the rolling resistance is proportional to the velocity at the point of contact, or it is proportional to the normal reaction. There's some, from simplified to very complicated models of rolling resistance, because this is there's quite literally a lot of money riding on this in automobile engineering, modeling rolling resistance. So it's actually quite widely studied in the field of tire mechanics. Okay. All right. So we have one more question related to the certification. How will I get the certificate after I complete the course? You will get an original certificate that I think comes to you by mail, but you'll also get a PDF version online. You can download and print that online version out. So I have a feeling that that should answer your question. All right, so let's take the next set of questions. We are now almost halfway into our discussion of dynamics. And I want to ask you, how many of you feel you have a good handle on drawing accurate free body diagrams? Like I said many times in the way I solved example problems, at the end of this course, if you are able to draw a free body diagram correctly, you've achieved everything you need to achieve with this course. So I want you to focus on being able to draw quantitatively accurate free body diagrams. If you can draw quantitatively accurate free body diagrams, you've learned dynamics well. That's all you need, because you can make mistakes in the second part, which is applying the laws of motion, but given some time we can verify and get those mistakes out. If your free body diagram is not accurate, you'll never be able to solve that problem correctly. So please pay attention to quantitatively accurate free body diagrams. That's very important. Okay, how many of you feel you're able to draw quantitatively accurate free body diagrams? I think the assignment solutions are best obtained through your peer network. As much as we would like to validate them, I would say let us use the 400 odd students who are all solving example problems in this course. We have about 400 students who have submitted at least two of the four assignments and the two later assignments. There's several more who have at least submitted one assignment. So we would like you to dig into that peer network. Please post your specific questions on the forum, and one of us will be able to validate the answers that are created from that peer network. So please take advantage of that, I would say. Okay. Next question. Yes, exactly. I have a question here related to the direction of friction. We can't unmute our microphone. Okay, let me answer the question related to let me answer the question related to the direction of friction. The beauty of the way we solve the problems in our class is that you do not need to know the direction of friction. You only need to know the direction of friction a priori if you know there is sliding. Okay? And if you know there is sliding happening, then you only need to know the direction of it. It opposes the motion. But in every other problem, you can start by assuming a certain F and give it an arbitrary direction, and it would come out to be negative if the chosen direction you take is opposite to what the problem wants it to. So don't worry about the actual direction up front. Okay. One more question that says I need more time to draw accurate free body diagrams. Um, sure. Why don't I do this? We'll create a whole set of situations in which you'll be asked to draw free body diagrams, and we will provide solutions to that set of free body diagrams. So where there is a situation and the free body diagram, quantitatively accurate to start with, and learn how to draw free body diagrams using that problem set. So we'll post that along with the question paper number 6, assignment number 6, that will be uploaded soon. Can you provide us some kind of PDF with questions and its solution? We will do that in the case of free body diagrams. We will certainly do that. Okay, any other questions? Nati? Can you hear me? In an ideal truss member, the does not affect. So in indeterminate structures also, the length of the truss member itself does not matter directly in terms of the load it bears. Okay, but when you do the structure calculation, you do not know which. I mean, there is an ambiguity, and that is the reason you have indeterminate structures. So even there, I don't believe the length of the structure, the length of the truss member, has a bearing. Mechanical engineering trusses, they're all over the place, Vishwat. Well, the first one, I mean, the biggest application is in civil engineering. Okay, so essentially all the load-bearing structures are trusses. But in mechanical engineering, the place where you find trusses are in long dynamic arms. So for example, you look at these construction sites where there's a long arm that is being used to place, prefabricated buildings. That long arm may have some dynamics to it, meaning like to be able to place the arm at a point, but the arm itself may be a truss structure. So it's a truss structure that is moving. So there is a static analysis of the truss as well as a dynamic analysis of the arm. So at that scale, that is one possible application where it is a truss occurs in mechanical engineering, but it's actually less common. Trusses are more common in civil engineering problems. Is there any significance area under the shear force diagram and bending moment diagrams. Well, the area under the shear force diagram basically tells you if the total area taking into account the sign, okay, is 0, that basically says there are no external moments acting on it. And likewise with bending moments, the area under the bending moment diagram is less easy to imagine. But if the area under the shear force diagram, taking the positive and negative aspects of the area into account, the total area is 0, then that only means there are no bending moments, external moments or couples acting on the beam. All right. Are there any transverse forces in trusses? No, that's the whole idea of a truss member. That a truss member is held by two pin joints, and that pin joint can only cause a force in this direction, tensile, in compressive or tensile. It cannot cause a rotation, a couple, because a pin joint cannot sustain a moment. Okay, therefore, it is only intended to look at tensile and compressive forces. How to get a contra-flexure point in the bending moment diagram if we get from the load diagram? I don't quite understand your question, Jagannath Prasad, but I will email you an answer after I look at what you mean by this. So please email me a slightly more detailed question, and I'm happy to take it up and send you an answer back. Indeterminate structures, but it affects member force in the case of indeterminate structure. Okay, Anupam, I will refer to, I will look at your question also in detail and get back to you with the correct answer if I'm wrong, and I will confirm my answer if I'm right. All right, I will look into that as well. I mean, the length does affect in a very simple way if the trigonometry of the structure is altered. We are not talking of that. Let's be very clear about it. So if I take the same trigonometric structure, scale everything up by a factor of 2, okay, scale all the lengths by a factor of 2, the forces in that second structure where all the lengths are scaled by a factor of 2 versus one where they are not scaled by a factor of 2 is not affected by the length. That is my claim. Okay, but I will check what you have to say, Anupam, and get back to you. Okay, any other questions? Jagannath Prasad, I will take down your question and get you an answer by email to you.
It is a point where no bending up. That's right.
Okay. Okay, the center of percussion is a very interesting concept. I will solve an example problem related to that. It is essentially the point at which if a force acts, then the point where the structure is anchored experiences no load. And we'll solve some example problems related to the center of percussion. It's a very interesting concept. I will, it should be more clear, Chetan, when we do that. Okay, Pratik, you have a request for us? What is it? Kinematics of machines. We're going to avoid any more discussion of kinematics. This is an 8-week course of both statics, kinematics, and kinetics, all three aspects of engineering mechanics. and it's difficult to go deep in any one of these three areas. So we're going to pretty much restrict our discussion of kinematics to whatever is needed to analyze kinetic systems, which is what we're going to do this week and the next. Okay, so that pretty much is the reason we are unable to go much deeper.
Probably after all the lectures are done, all the 8 weeks are done, we can give some hints or for each and every assignment.
Okay.
Before the final exam. So,
okay.
Yeah.
So we will try to post some version of the solutions before you go for the certification exam for all the assignments that have been given to you till now. I hope that helps you in your preparation in the 2 weeks that you will have between when this course ends and between when the next between when the certification exam is going to be conducted. Okay. Any other questions? Let's quickly get a feel for where you guys are all located. Where are you located? Can you please type in your locations, which town you are in, just so we get a feel for, a pan-India feel for this chat. Pratik, where are you located? Those of you that are joining now, please type the location where you are joining us from.
Hello, sir. Hello.
Okay. Naveen, do you have a question? Jagannath Prasad, yes, if you've not done any assignment, you still can take the final exam, but you will lose the 30% or whatever is the score that is assigned to the assignment part. So you will still have to get 60% overall. You have to get that 60% only from the 70% that is set aside for the final exam. So it's your choice. The assignments are and the deadlines associated with them are enforced by NPTEL. Please do join as best as you can. Please do submit your assignments as best as you can. Now, you can submit all the assignments between now till the completion of the course. But like I said, it is only going to help you in the final certification stage.
Yeah.
Ravi.
Hello, sir.
Any other questions? Or would you like to close this chat?
Hello.
Naveen, are you intending to talk to us?
Sir. Hello.
Naveen, are you intending to talk to us?
Hello.
Anupam, degrees by themselves don't mean anything. We are going to live in an age very soon where your knowledge is going to be your degree. And you have to explicitly demonstrate that along the way. So writing degrees after PhD, uh, it is for someone else, not for us, right? What remains with us is the knowledge we gain along the way. So if we keep our focus on learning new things all the time, continuously learning new things all the time, we'll be far ahead of our competition. Doesn't matter what our degrees say. I met a student today. He came to my office. This guy is running a very successful robotics business. He started that in his third year as an undergraduate student, and then he has not even completed his BE BTech. He's just remained as an entrepreneur and he's doing very well. The first thing I told him is to finish his degree because it is important to have a degree as a general way of gaining confidence. But that in itself does not mean anything. It is the knowledge that the person has that is much more important than the actual degree given to you. I mean, the degree given to you is for someone else to give their benefit of doubt to you. That's all. After we open our mouth and start talking, it is what we say and what they hear that becomes much more important than the degrees that we had next to our name. Right? So I hope that answered that question. What about a project under you in summer vacation? Pratik, you're welcome to write to me. But the truth is that we usually get a lot of requests for projects here at IIT. You're welcome to write to me and I'll be glad to consider it just like I do all else. Okay? Good. Any other questions?
Hello, sir.
Okay, good. Looks like we've hit a lull there. Thank you very much. Thank you very much for coming online. I hope you enjoyed this. We will try to do this at least once more before the certification exam, before the course closes. You are welcome to ask, come prepared with more questions at the time, and we'll hold a more detailed discussion. Okay, thank you very much. This video should be available online for you to catch. Okay, good night then.
Thank you.